So if you look at this one here, cache memory, I have already mentioned the level of the memory hierarchy closest to the CPU is called the cache. So assume that the processor requests data called xn. If it is not found, then it is called as cache miss. So it has to fetch the data from the main memory and place it into the cache. But there are two questions. How do we know if the data is present? How do we know if the data that we are requesting is present in the cache memory? I'm talking about the memory level which is closest to the CPU. How do processors identify? What do you think? So you have been dealing with data, reading data from the memory, right? So how do you read the data from memory? You specify the address. Agreed? So you specify the address and processor go to that address, and whatever is stored at that address, it will read the data, right? Similarly, we have to specify some address into the cache block. So we have to find out what is the address is. And second question is, where do we look in the cache? Okay. So there are different strategies to arrange data from memory into cache, because the cache size is very small compared to the main memory size. So there's one strategy that we will be studying only, which is called the direct map cache. There are a couple of different associative mapped cache is also one of the other thing, but we will be discussing only direct map cache. So the simplest way to assign a location in the cache for each word in memory is to assign the cache location based on the address of the memory in a memory. Okay. So whatever the address location of a word in the memory, it will be assigned the same address in the cache. It's called the direct mapping. So when the processor requests the data, it has to actually determine where that data is placed in the cache. So which means that we need to find a block in the cache where data is located. This makes more sense to you, this example. So here, this is a cache. Consider there are only locations which are the number of locations are the power of 2. So here, what is the power of 2 here? What is the size of the cache? How many blocks are there? Just consider these vertical blocks as one block. So there are 8 blocks, okay? So it's a power of 2 to the power of 3, right? So when we have 2 to the power of 3, which means that we can represent each block with 3 bits, right? And this is the memory. So we need to come up with a strategy, because the cache size is smaller, memory is bigger. So when we do not find the data in the cache, we have to reach to the memory and grab the data from the memory, and from the memory we have to place it in a cache. But where do we place it? Okay, so this is the strategy that you see it up here. So we use the lower address bits to index blocks in the cache. So here, for example, 001, so these 3 bits, 001, again 001 here, 001 here also, all of these data will be placed here. So for example, processor requests a block, let's say this 9, okay? Request a data from the address number 9, okay? So how does processor know whether this block contains the data of this address 9 or this one or this one or this one? Because all of them will be placed here one by one. But do you get an idea of how these blocks are placed? So when the data is requested 00001, so this will be placed here, okay? So next time when the processor requests this data, processor do not need to go to the memory, it can fetch it from here, okay? But for example, if the processor next requests a data from 01001, which is the address number 9, so this contains some data, but how do processor know if this is actually the data that is being requested, or if the data belongs to this location? How do you think processor can identify?